I want graphs. The purpose of my examining F and F prime and F double prime is to draw decent pictures. Even if I've got this amazing little computer in front of me that will draw things for me, I need to know that I have all the important pieces in the picture I create here. So I'm going to graph this first function. X squared minus X minus 132. And if I go to my standard window, I have a major problem. That's the correct picture. What? The hell do you mean that's the correct picture? There's nothing there. The equation's in there. I hit the graph button. Why don't I see anything? It's not in the window. I don't know where to look. I looked in the wrong spot. As a matter of fact, if I go back and look at that, y-intercept, if I put in 0, is down at negative 130. My window only goes down to 10. So clearly I have the wrong picture. Let's try this one. You can see it thinking in the upper right-hand corner. Again, that's the correct picture. Wait a minute. If I put in 0 to this equation, I get 0. I'm on the graph. Why don't I see anything? Oh, no, that's this one. We're on this one. This is an x cubed function. What's an x cubed function supposed to look like? I see now here. Supposed to. I don't have a good answer for that. I know what this is supposed to look like. This is a sine function. What's sine function supposed to look like? Wait. This is useful. It's a sine, right? What's the biggest value you can get out of sine? And the smallest? So this Y window is absolute crap. Let's change it. Not the X's. Leave the X's alone. There, we'll change the Y's. What? This looks like a seismograph in the middle of an earthquake. I'll change my X's. Ready? Shouldn't make that much of a difference, right? What the hell is going on here? You know as well as I do that is not what's supposed to be coming out of this picture, right? It's supposed to be a sine curve. What the hell is going on here? My calculator is stupid. It does what I tell it to do. And what I told it to do was to go from -3 to 3 in X, divide that into as many pixels as I have across this page, which in my case is 96. Take each of those numbers and plug them in. Plot the dot and play connect the dots. That's all it's doing. It's connecting each dot to the next one. And my calculator is dumb. And the fact that one dot is up here and the next dot is down here, okay, I'll connect the dots. Now, given that some of you have a more recent version of the calculator than I do, you may have a different screen and get very different looking pictures than this. And this is one of the wonderful problems with technology. Somebody upgrades something and all my life, hard work and stuff goes, well, what do I do now? What happens for backwards compatibility? What happens to technological connection? Fine. I can't just plug and chug. That's not going to cut it. What I need to do is come up with a way to say, this is where the interesting things are in my picture. Now, let's make sure my picture shows all of those things. And I need to do this systematically. I need to do this carefully and in some semblance of an ordered fashion. So how can I create such a system? All right. I need to start with algebra. I need to start with all the things I know just by looking at the equation itself. Then I can see what interesting parts of the function are where, and I can find them all. So before I do any calculus at all, what information can I get directly from f of x without any sort of calculus work? Sure, I can get a y-intercept. I might even be able to get x-intercepts. So I can get intercepts. And I get the y-intercept by setting x equal to 0, plugging it in, seeing what comes out. I get the x-intercepts, although there could be more than one of them, by setting y equal to 0 and solving what comes out. Sometimes that's easy, sometimes that's a pain in the ass. But that's algebra, and I should be able to do it. And if I can't, I'll just say, all right, this is too complicated for me to solve right now, we'll come back. There are two caveats here, two things to be careful of. You might not be able to plug in x equals 0. Why not? Which would make x equals 0 not part of the domain. I should check domains first. Because I'm not allowed to divide by 0. I'm not allowed to take the square root of negative numbers. I need to know where my function is broken, because those places are going to be important. If there's an x value I can't use, might have an asymptote there. Not always, though. What else could happen instead of an asymptote? Could just have a hole in the picture. We did x squared minus 4 over x minus 2 and just had a hole instead of an asymptote. But if I'm thinking of asymptotes, I don't just have vertical asymptotes. Sometimes I have horizontal asymptotes too. Now, sometimes horizontal asymptotes require me to do a little calculus, because a horizontal asymptote would be what happens as x goes off to infinity. That's a limit. And x going to minus infinity. That's a limit. So I might need to do what we were doing on Friday and look at L'Hopital's rule. As we go off to plus infinity or minus infinity, we could get infinities in our y values. The three examples I gave, none of them had any asymptotes. How convenient. But one of them was a trig function. When I took trig, it told me I didn't have to do the whole graph. I just had to do what? A period's worth. I have to know what's going on before it repeats itself. So I need to be able to check if there's a period or if there's some sort of symmetry to my graph. Now, there are a couple of particular types of symmetry we looked at back in the algebra classes, and I talked about symmetry where a function is even. What's it mean for a function to be even? Doesn't just have to do with the ends of the graph, it has to do with the whole graph. Say that again, Shalanta. If I take the left side and I fold it over the middle, right over the y-axis, everything on the left is exactly the same as everything on the right. So that means when I plug in a negative value for x, I get the same exact result if I plugged in the positive same number. The things on the left side where x is negative are exactly the same as the things on the right side where x is positive. Well, if I've got even, I've got odd as well. What changed in that sentence if I think about odd? Unfortunately, no, it's not over y equals x. Inverses are over y equals x, but that's where we're talking about two different functions. This time, if I bring this stuff over from the left, it's not the same. It comes over and up. It's diagonal symmetry. Technically, it is symmetry through the origin. If you draw a line from a point in the first quadrant to the origin, it's going to hit the graph again in the third quadrant. If you're in the second quadrant and you draw a line through the origin, it's going to hit in the fourth quadrant. They're going to be diagonally symmetric, which means when I flip it over, I have to go from bottom to top or top to bottom. That means putting a minus sign on the y. A period, whatever my period may be, means it repeats every so often. Function is periodic with period p if, when you add p, you get exactly the same value. Almost all of these things, almost all, require very little calculus. They require me to remember some things about algebra and trig and graphing that we did back then about end behavior, whether functions were even. Now I get to do the math dance again, right? All that fun stuff. But I did that when I was just looking at these graphs. I said, oh, x squared minus x minus 132, that's a parabola. It should look like this. Where is it? Clearly, I had the wrong picture. A cubic equation. Cubic, wait a second. I could go through and I could ask all of these questions about those equations. But if I really want to make sure I have stuff in the picture, I should be finding for that parabola, what should I be finding? What's the interesting thing about a parabola? They all look like this. They are even functions sometimes. If they're off to the side, they're not even, because you have to fold right over the y-axis. So it's got to be centered to be even. If it's moved. Where do we pin down a parabola? The vertex. I need to know where this is. And then I need to know, does it go up from that or down from that? Hey, wait a minute. Is it a minimum or a maximum? I'm asking about my derivative, my critical numbers. So now I can say, what I really need to look at is not just f, but f prime as well. Critical numbers and extreme values give me intervals of increase and decrease. And that's going to give me a really good way to figure out what the window should be if I know highest points and lowest points and where the graph is going up and where it's going down. I can get all the interesting stuff into my window. I think. Because my rate of increase and decrease may change as I go from side to side, right? I might be going up a little bit and then up more, or up a little bit and then down, or up less. And that's measuring change in increase. And that comes from change in slope. Comes from what? Ways to measure that. That's the right way to phrase it. My second derivative. Tells me where I'm concave up, where I'm concave down. It's another way to get at my extreme values. And it gives me the ability to say, oh, well, the curve should be coming up or down. Bending in certain directions gives me a better image for the picture. Now, I'm going to tell you that graphing calculators are a quote unquote recent thing. And the best graphing device I had when I learned calculus was this, and a piece of graph paper. We have amazing pieces of technology. I want to put it to use, but I need to know where I'm looking before I start drawing pictures arbitrarily. I see this happen a lot. I see people reach for their calculator immediately and then look at something and go, why isn't there anything here? Or what am I actually looking at? I want to know what I'm looking for before I even pick this up. An example from the bottom to the top. Let's take it all the way up. let's start at the beginning. And originally we were thinking about starting with intercepts, but I said before we do that, we should check what? Not quite. I should make sure I can plug the things in, right? I need to know the domain. Okay, so we look at this function, and I say to myself, what kind of function is this? It's a polynomial. Where are polynomials defined? Everywhere. Means I can plug in any number you want. And that means that I can find intercepts. My y-intercept, I plug in 0. Hey, wait a minute. If the y value that comes out is 0, that also makes that an x-intercept. I now have a point on my graph. To get the x-intercepts in general, I set y equal to 0. Y is the output. So I need to solve that equation. This happens to factor. Since I can factor it, I now know that either x is 0 or 8 minus x squared is 0. So x squared is 8. X is plus or minus root 8 or 2 root 2. If you want to simplify it, I'm not going to require that. The square root of 8 is somewhere between 2 and 3. I have 2 more points on my graph. This is a polynomial. Polynomials are usually not periodic. They don't repeat themselves. So finding a period is probably not a useful trick here. What about symmetry? What about asymptotes? Because those were the other things that were listed in my things I can find from F. Either symmetry or asymptotes. I'm sorry, I can't quite hear you. Because that just means there are no vertical asymptotes, right? The domain is all real numbers, there are no vertical asymptotes. What's going on as I go out to infinity? Whether I do it on the right or the left, I should know what's happening as we go out. 8x squared minus x to the fourth. As x gets bigger and bigger and bigger and bigger, which of those two numbers, 8x squared or x to the fourth, is going to be bigger? The x to the fourth is going to be a lot bigger, right? And that's being subtracted. So when x is really, really big, I should be going down. When x is really, really big negative, what should be happening? Because x squared and x to the fourth make negative numbers into positive numbers. The answer to both of these is minus infinity. As I go out, I'm going down. If I think of myself as going from left to right, way over here on the left, I should be coming up. Way over here on the right, I should be going down. I think of my end behavior as going out, but I think of my increase and decrease as moving from left to right. Wait a minute. I'm going in the same direction as I go out. I hit the same point on the left and the right. I saw nothing but even powers. Symmetry. Should I check, maybe this function is even? You check to see if a function is even by putting in negative x and simplifying as much as you can. What happens when you square a negative number? So this is going to become just x squared. What about here? It's going to become just x to the fourth. Wait a minute. That means this is 8x squared minus x to the fourth. That's the same as the function I started with. It is even. This just made my life a lot easier. Because if I know any y value on the right side, automatically know the same y value on the left side. I just cut down the amount of work I have to do. I'm a lazy SOB. I like this. I believe I've exhausted my list of things I can figure out just from f. So let's look at f prime. I know later I'm going to want to look at the second derivative as well, so I might as well take my derivatives now. Matter of fact, you could have taken them back at the beginning if you wanted to. I think that's usually a little more work than is required right at the beginning, but there's no reason not to do it now. What is f prime of x? And f double prime of x? Great. From f prime, what do I want to get? My critical values. That means I need to set my derivative equal to 0 or where it doesn't exist. What kind of function do I have for a derivative? Polynomial, so once again, it is defined everywhere. The only type of critical number I need to worry about is where it's equal to 0. So where is that? Yes, if I put in 0, I get out 0. That makes sense. But I should find others. If I pull out a 4x, I'm left with a 4 here and an x squared. So either x is 0 or a number of people on the homework question that asked to find critical values or asked you to find extreme values forgot to do the plus or minus when they did square roots. Be careful. So what do I do now? I make my sign chart. Whether you make it vertically or horizontally, whether you make it one line or multiple lines is up to you. But now I'm looking for intervals of increase and decrease. By the way, I left it as 4 minus x squared up here. I could factor further 2 minus x to plus x. Well, then each of those factors on a separate line will change sign once. You're welcome to use this factored version if you want, but this factor will change sign twice. Test numbers. Pick numbers in between my critical values, and off to town we go. Plug in the test numbers and just write down whether the answer is positive or negative. And then since I multiply these pieces to get f prime, I multiply these signs to get f prime. So I see increase, decrease, increase, decrease. Here is my first chance to double check myself. Does this match what we thought was going to happen based on the limits going out to infinity? As we go to infinity, we're going to minus infinity. So we're going down as we get more and more to the right. If we think of ourselves as going to the left, we're working backwards, yes, we'd be going down here. We're going to minus infinity. This jives with what we came up with earlier. I'm happy to see it. Intervals of increase and decrease, I should write those down. Increasing on. There are two intervals of increase. What are they? We stop at that first critical number. And now here's me being a pain in the ass pedant. You could just put a comma between these, but the appropriate mathematical symbol is you're increasing if you're in this or if you're in this. That upwards union symbol is the logic term for or. What's my other one? And I'm decreasing on these two. Again, the numbers have to be in the right order. Left to right, left to right. The intervals themselves don't have to be listed in that order. You could just as easily write 2 to infinity or -2, 0. But me, I'm going to work left to right. From this chart, I can tell about the extremes, right? What are my extremes? Donna? Talk to me. You're waving your fingers at me. Okay, negative. And 0 is a minimum. Write it down. Local max at 2 comma something. Negative 2 comma something. Local min at 0 comma. Hey, wait a minute. We already worked out the y value for that. Exactly. Because it was one of our intercepts. What I now need are those y values. Go back to the original equation, plug it in. I only need to plug in one of them, y. Symmetry. Only have to plug in the one on the left to get the one on the right, or vice versa. Plug in 2. 8 times 2 squared, that's 8 times 4 is 32. Minus 2 to the 4th. 2 times 2 times 2 times 2 is 16. 32 minus 16 is 16. However, if you hate doing that sort of algebra in your head, you don't have to. I told you I hadn't even picked it up yet, right? Put in y1. Put our equation, our original equation, into y1. 8x squared minus x to the 4th. I'm not going to graph. I'm going to quit from here out to the home screen. And I'm going to tell the calculator, plug in 2. Under the variables button, which is right here, that second column says y variable. So if I hit the arrow, it gives me a chance to look at all the y values I've got. I want to plug into y1. What do I want to plug in? I want to plug in 2. Look, it's like f of x, right? It just knows use the function in y1. There you go. I don't have to do it by hand. Yes, Ed. Variables, functions, and then y1. And you could plug them in both. Oop. Helps if you put the parentheses in the right places. Parentheses. There we go. This automatically tells me something about my window. If I want to graph this and see important parts, I have to go at least as high as 16, right? Should probably go a little bit above that. I have to go at least as low as 0. Probably a little bit below that. I'm already in a better picture position from top to bottom. What about from left to right? What is the most negative x value I have encountered so far? Negative root 8. Root 8 is negative 2 point something, right? It's between negative 2 and negative 3. It's further left. Same thing on the right. Square root of 8 is bigger than 2. So I know I need to go out at least past 2, even though 2's are here. I had numbers further away here. So I probably need to go out to say negative 3 or negative 4 on the left, 3 or 4 on the right. There. That should show me the maximum, maximums, minimums, and all the interesting pieces and the intercepts. And everything outside this picture is boring. Because as I continue to go to the right, I just continue going down. As I continue to go to the left, I continue going down. Clearly, we have sections of this graph that are concave down and sections that are concave up. I should find out where those changes happen. Where do I get those from? My second derivative. Well, we already worked out the second derivative. All I need to do is set it equal to 0 to find the x values where my changes of concavity will occur. All right, let's 12x squared equals 16. I divide, I get x squared is 16 over 12, 4 over 3. So when I take the square root, I get x is plus or minus 2 over the square root of 3, or you could write the square root of 4/3, which is somewhere between 1 and 2. Because 4/3 is a little bit bigger than 1. Its square root will be a little bit bigger than 1. But 4/3 is definitely less than 4. So the square root is going to be less than 2. What should I pick for my test numbers? Zero absolutely should be right in the middle here, right? We already know what the picture looks like. My concavity should be obvious at 2 and minus 2. Isn't that my second derivative test for extreme? It's another way to double check myself. I should absolutely get that this is concave down at -2 and concave down at 2 and concave up at 0 because those are extreme values. So it is to my benefit to use the critical numbers we had earlier. And then I plug into f double prime of x. If I put -2 in here, I get 16 minus 48. That's negative. We're concave down. If I put in 0 here, I get 16. We're concave up. If I put in 2, 12 times 4 is 48. 16 minus 48 is a negative number. So both are points of inflection. Our graph is concave up on the interval from negative √4/3 to √4/3 and concave down on minus infinity to minus √4/3 or 4/3 to infinity. How do I get the y values for those points? Plug them into the original equation, which is already graphed for me. So I can use my technology the same way we did before and say hit the trace button and put in x equals the square root of 4/3. Well, that's a beautifully disgusting number, 8.888888888. Okay. But that's the number here. That's also the number here because of my symmetry. Now I want you to understand something. For me to go from the ground up, that took half an hour. I got a lot of stuff. This is an amazing magic box. Because I want you to understand that when I took calculus, this didn't exist. And my next step was to spend the next 5 minutes drawing the graph to scale on a piece of graph paper with a ruler. Which side? I will also tell you that I rigged this problem, because this particular problem had no asymptotes, had no places where we had to worry about weird limit behavior or period or anything like that. There are 6 examples in this section in the text. You should read them all, because they will all add things to our discussion. When we make a sign chart where we have an asymptote, 1 over x, right? X is equals 0 is not a critical number, but it's still a place where things could change. I usually, in my sign chart, indicate that 0 is not actually a critical number by putting a dashed line. Aren't asymptotes dotted lines? Some people will put a little open circle on the axis. Some people will go so far as to write a U on the bottom for undefined. That's still a place I need to take into account when I am doing my sign charts, but I have to take it into account differently. Questions? All right, one more for you. Clearly not the whole problem. I want to point out something interesting. I talked about horizontal asymptotes. I talked about vertical asymptotes. There are others. 4 functions that are rational. If the degree of the top is 1 bigger than the bottom, then we actually have an asymptote that's diagonal. The real question is, how do I find it? And the answer is, I divide. Here is a algebra memory to drag up from the depths of hell for you. Long division. I know you did this. If not, there are links to review sections on our Canvas page. There are at least 2 different reviews of this on Khan Academy and on Patrick JMT tutorials, both of which should be linked in our list. You need to be able to do this kind of division. The last example in the text does one just like this. But that has put me right up against the clock. And it does mean also that we've covered 3 sections. This is today. This is Wednesday. This is next Friday. I'll see you all on Wednesday. No, there's a final. Yes. If you came in late, come get your homework. Otherwise, I don't know you're here.